Hello, Curran here. This video is about melting and munging data for visualization. We're going to make this line chart here from the United Nations population data, but it's not just making this line chart. It's all the melting and munging that needs to take place to get the data into the right structure to work with this line chart. If you followed the previous video's line chart with multiple lines and circles on a map, and you're interested in doing data processing in JavaScript for data visualization, then this video is for you. The topics we're going to cover here include melting columns into rows, and by the way, that melting terminology is from the R community, filtering out undesirable values from the data, merging multiple data tables together, correctly parsing dates with d3.timeparse, and renaming long names for labels. This visualization shows population of each country at one point in time, namely 2018. What I'd like to do is take this same data and represent the change in population over time by using multiple lines on a line chart. The idea is that each line can represent one country. I'm going to start by forking this visualization, and I'll rename it to melting data for multiple lines. The data we want to show is already being loaded in this example, so I'm just going to take this load and process data module and copy it over. Over here, I'll create a new file called loadandprocessdata.js, and then I'll copy the implementation from the map and paste it over here into this new empty file. And we also need to import this. So over in our index.js of the map example, see here it gets imported. So I'm going to copy this line here and paste it over in our index.js in this visualization. Import load and process data from /load and process data. And then at the bottom of this file, in place of loading this CSV data, I'm going to use that function instead. Load and process data, and we're going to invoke that as a function. The parsing will happen inside of that load and process data function, so I'm going to delete that. And this function here, it just takes as input data and then passes that into render. So that's equivalent to just passing render in here, like that. But for now, let's just focus on load and process data itself. So I'm going to comment out that .then, so we just run the code that's in load and process data. Just to get oriented here, I'm going to comment out all of this code and then just console.log un data. And let's see what we've got. Okay, topo.json is not defined. That's all right. We're importing it here, but we don't actually need that import right now, so I'm just going to comment that out. Now when it runs, it outputs this array. And let's take a look at each element of this array. These are our original rows here, and we can see that we have a column for each year, 2015, 2016, 2017, 2018. And these are the population values for these years for one particular country. So if we scroll down, we can see that all these numbers correspond to the whole world in this case. This is the original data table. In here, there's different columns for the years, and each row corresponds to one value for this field here, region, subregion, country, or area. This is what you might call a wide table because it has a lot of columns. Or you could think of it as an ice cube that you could melt into a long, skinny icicle. This is the format of the table that we need to transform the data into, where there's one column for the year, a column for the country, and a column for the population. This has population values for each unique combination of year and country value. See, if you scroll down, the country value changes, the year changes. It's all the unique combinations. This is what you might call a long, skinny data table. This is the format that works well when you make line charts with multiple lines or other visualizations with D3, because you can easily use d3.nest to separate these into separate arrays based on this country column. It also makes it easier to, for example, compute the min and max population values, because you can just compare across the whole data table, all combinations of country and year. Let's melt these columns into rows. So what we want to do here is make a new data table that's going to have a melted version of this, where we're going to have one column for the country name or country ID, another column for the year, and a third column for the parsed population value. We can do this using a nested for loop, where the outer for loop loops over all the original rows, and the inner for loop loops over all the years. And the years go from 2015 to 2100. And before I forget that, I'm just going to make new variables for min year and max year. Min year is 2015, and max year is 2100. So let's go about writing that nested for loop. We've got un data, so we can say un data.forEach. We can pass a callback that takes as input d, one of the original rows, and then we can loop over the years. So assume we have an array called years that has all these years from min year to max year. Then we can say years.forEach. Year will be the input to that callback. And here is where we can construct a new row object. We can say const row equals a new object where the year is the year that gets passed in. And on this row object, we're going to want to put country and also population. So this is the overall structure of melting these columns into values for rows. But now we need to define years, country, and population. So let's start with defining years. We can say const years equals, well, we want to get an array that starts at 2015 and goes to 2100, and luckily D3 has a nice utility called range for this. We can import range from D3, and then we can say, all right, our years should be the range from min year to max year. And then I'll just console.log years to see if this worked here. And I'll just comment out this for now. All right, when we say console.log years, it prints out this array of integers that goes from 2015 up until 2099. See, the range function doesn't include the last value, so to fix that, we can say max year plus 1. Now we get an array that goes from 2015 up to 2100. All right, that's how we can use range to define this years array. So I'll get rid of this console.log, and we can move on to this section here. What we need to define next is the country. So I'll make a new variable for country, and that's going to be d at a key that's a really long name. I don't remember what it was. But to figure out what it was, I'm just going to bring back that console.log un data and see what that is. If we look at the columns, this is the one, region, subregion, country, or area. So I'll copy that, and then we can paste that in here as the key. And the last thing we need for our row is the population. So I'm going to make a new variable called population, and that's going to be d at the particular year that we're looking at. So we can use the year variable there. And we had some tricky parsing logic from earlier. Here it is. We use plus, so I can say plus d.year. And I remember these strings had spaces in them, and we needed to multiply by 1,000. So I'm going to copy this logic that we came up with earlier and paste it right there. That should complete the definition of our row objects. Let me just say console.log row for each of these rows, just to see if it's working. All right, it seems to be working. We've got country, population, and year. The last step here is to construct a new data array and push all of these new rows onto it. So before that nested for loop, I'm going to declare a new variable called data and assign it to be an empty array. And this is the thing that we're going to return at the end. So I can say return data. And for each of these rows, instead of console.logging them, we can say data.push. Now, data is an array of all these row objects, and there's one row object for each unique combination of year and country. Let's just console.log data to just check if it's right. All right, we have a huge array with 23,000 entries, and each one of these entries has the year, the country, and the population. Although it does have entries that are not exactly countries. There's one for the world, and there's categories like more developed regions. But let's deal with those later. Let's filter those out later on. For now, let's get our line chart working with this new data. Back in index.js, let's bring back that call to render after the data loads. And I think it will be breaking right now, because the accessors from earlier don't match up with this data anymore. We need to update X value and Y value and color value. The X value can be d.year, and the Y value can be d.population. And the color value can be d.country. All right, we're seeing something here, but I'm remembering that we're using scale time, which accepts dates, but d.year is an integer. So let's parse those integers into dates. Over in our load and process data.js, we can say year. That can actually be a new date where we pass in the year. That didn't seem to work. See, the axis is not, it doesn't look like years. I think that's because the date constructor, you need to pass it in a string, otherwise it won't behave correctly. So to convert this number into a string, we can just concatenate it with the empty string. There we go. Now we see nice years on our timeline. All right, we're starting to see something here, but there are many problems still to be resolved. But still, already we can read something interesting to me at least, that this population model forecasts that the population of the world, the rate will slow down, and the human population on Earth looks like it's going to plateau around 2100, and that surprises me. So let's just fix this up until we have, the finished product. One thing I'm noticing now is that the README is out of date. I'm just going to delete this README. And the title doesn't make sense anymore, so I'm going to change the title. Instead of saying a week of temperature around the world, it can say population over time. And for the y-axis label, temperature does not make sense anymore. I'm going to change that to be population. And the number formatting is off for the y-axis. So let's change that too. For the y-axis, we can specify .tick format to be format of, I believe it's S for the SI units, and format I think we need to import from D3. Yeah, I'll import format from D3. I remember solving the same problem before with this world population area chart, so I'm just going to use this same solution again. I'll copy this logic here and go back over to our line chart, and then for the y-axis we can specify our custom tick format, which I'm going to paste right here. This function takes as input a number. It uses the 0.1s format and then replaces G with B to signify billions. So we can use that for our tick format. Now we get these nice numbers here, 1B, 2B, 3B. One problem I'm seeing though is that it's 10B 3 times. So I think we need to increase the precision. What if we say 0.2s instead? Alright, now we get 10, 11, 12 billion, but we get this 0.0, which I find undesirable. I don't know how to solve this using the format string, but I guess we could just do another dot replace, where we replace 0.0 with the empty string. Alright, that works. That looks good to me. Now let's address the problem of there being too many lines. There's just so much clutter here, and by the way, it's becoming black because we're using the multiply blending mode. Let's filter out the undesirable values and isolate the ones that we want. What I'd like to do here is just have a few lines for these top-level categories, like Asia, Africa. We can figure out the set of these categories by checking, is the string all caps, and is it not world? So let's do that. Over in load and process data, here's the line where we extract the country. And I'm realizing now that this could be in the outer for loop, so I'm going to move it there, like that. Country is the thing that we can test against to filter things out. And rather than modify this, which we could do, I'd like to keep that plain and simple, and then do a data.filter statement out here to filter the data. And actually, that's what we can return from this function. So return data.filter, and we can pass a callback that takes as input D, and we can return something based on d.country. And let's make that a separate function. Let's call it isCategory. We can say isCategory of d.country. And now we can define isCategory separately. I think I'll define it up here. isCategory takes as input a country string. And this function should return true if this country is all caps and it's not equal to world, W-O-R-L-D. So let's decompose this. We can say all caps country, and country is not equal to world. Now we need to define all caps, and this takes as input a string and returns true if that string is all caps. So to check that, we can say, is the string itself equal to the string dot to uppercase? And to uppercase is built in on JavaScript strings. All right, that worked. See, we got Asia, Africa, Latin America, Europe, Northern America, and Oceania. Just to be consistent with the United Nations terminology, I believe these are what they call regions. So rather than isCategory, I'll call this isRegion. And instead of country, I'll just call this name. So all caps name, and name is not world. And then isRegion is what we can use down here when we filter. And I'll use name in here as well. Say name is that. And then the rows can have name. And then we can access d.name when we pass it into isRegion. Now over in our index.js, we need to use name as well for the color value. I find this to be very interesting because it looks like as of 2100, the population of Africa is going to be skyrocketing. And the population of Asia will start to go down around 2060. But for more context, I'd like to bring in the historical data that goes back in time as well. I'm going to go back to the source of this dataset. Download this spreadsheet again. And remember, the thing that we're visualizing now with our lines is actually this medium variant of future predictions So what I'm going to do is take this Estimates tab and export this as CSV. I'll delete these extra rows. I'll save it as a CSV file. Then I'll upload it to VizHub. I'll choose that file. I'll set the name, the source name, and the source URL, and then click Upload. Now we can bring in this dataset too and show lines that go back in time. So I'm going to copy this URL, and then back in our code, in our load and process data file, I'm going to add another line where we invoke CSV again, and we paste that URL to load that dataset as well. And you know what? We don't need this topo.json data anymore. So we don't need JSON from D3 either. Let's merge these two data tables together. Now this first argument here will be this medium variant. So I'm going to rename this to UN data medium variant. And then we're not getting topo.json data anymore. And I'm going to call this one UN data estimates. And what we're going to want to do here is execute this logic, but for these two different tables using different values of min year and max year. So what I'm going to do is move this logic into a separate function. I'm going to paste that up here, fix the indentation, and I'll call this function melt. And this will take as input UN data, and all this stuff happens in the body of that function. And you know what? This should actually take as input min year and max year as well, because these will be different for the two different tables. So I'm going to make min year and max year arguments, and then down here I'll say return melt, and I'll pass in UN data medium variant, and the min year will be 2015, and the max year will be 2100. And I'm going to get rid of these two lines here because those are arguments now. And then the max year will be 2100, and boom, we get our lines back. Now let's figure out what the min year is for UN data estimates. I'm going to console.log UN data estimates and take a look. Alright, when we console.log UN data estimates, this is what we see. The columns go from 1950 up until 2015. But we don't want to include 2015 twice, so let's say the max year is 2014 for this. So instead of returning this, let me just return the other melted data set. Melt UN data estimates, and the min year is 1950, and the max year is 2014. Alright, now we see a line chart where it goes back in time. See, in the past, the population of Asia has been dominant. But now let's combine these two different data sets. I'll get rid of this console.log, and what we can do is use .concat, C-O-N-C-A-T, which is a method on arrays. If you call .concat, it will concatenate the array that you pass in with the array that you call concat on. So what this does for us is it merges these two data sets together. And now see the line chart that we get. It goes back into the past, and it also goes into the future. I find this fascinating to just look at and study. Right now is somewhere around here, 2018. And judging from the past, the population of Asia is just going up and up and up. And that, I suspect, is dominated by India and China. But I had no idea that these population models show that the population of Asia will decline and the population of Africa will become more dominant in the future. This red line represents Europe, and it looks like the population of Europe is sort of at a plateau right now, and it's going to go down. Who knew? This green line represents Latin America, and it looks like the population of Latin America will overtake the population of Europe around 2030. And then for these bottom two, we've got Northern America and Oceania. But let's do a final pass on cleaning things up here. One thing that bugs me is that I don't understand why the time goes up to 2120. I mean, we're calling .nice on the scale, but still, it should only go up to 2100. And I think there might be something fundamentally wrong with the way that I'm constructing the dates in the code. We can parse dates correctly using d3.timeParse. See, here the code is calling new date and passing in the year as a string, but I think the problem here is that it's creating a date in my current locale, my current time zone. I think the proper way to parse years is to use d3.timeParse. So instead of using the date constructor, we can just make a function called parse year. And parse year we can define out here. I'll say const parse year equals d3.timeParse. And we need to import timeParse from d3. And if you need to work with timeParse, I'd recommend this example by Zen Armstrong. D3 time formatting example. It has some nice examples, and you could enter in your own dates and format specifiers here. But the thing I'm after is the year, because we have years. And this is the sort of special code for year, %y. So back in our code, we can say timeParse of %y. That should parse the year. And then when we invoke parse year, of course we need to pass the year in. And now we get our lines back, and see that? It only goes up to 2100. We don't have that extra space there. So that signifies to me that now we are parsing the years correctly. Next, I'm going to tweak the margin and the position of the color legend over in index.js. I'll change the right margin, and then I'll move around the color legend. So I'm just going to tweak this translate here. Oh man, why do they have to use such a long name? Latin America and the Caribbean. I think I'll just make the font size smaller for the tick text. Or you know what? I think I'm just going to replace and the with an ampersand. Let's rename this long name for the label. So over in load and process data, I'm going to get rid of this dead code there. When we extract the name here, I'm just going to call .replace and replace and the with ampersand. And that seems to have worked. See that? I'll do a final round of tweaking on the color legend. Tweak the margin a bit more. And I don't really like this wasted space here, so I think I'm just not going to call .nice on the X scale. And lastly, I think I'll change the title to be population over time by region. All right, there's our finished product. All right, that's all for melting and munging data for visualization. Thanks for watching. Take care.